This is a session for MLCommons to sort of help members and those interested understand how more easily to run the MLPerf Inference benchmark using the collective mind framework. The CM framework is an automation tool that Arjun will describe in more detail that makes it easier to reproduce the results of past benchmarks or to get the benchmark up and running in a basic way. It can be used by, say, new entrants who want to run inference and they want to get a functional foundation for optimization, or it can be used to reproduce past optimized results. And Arjun can talk about most of that. He's one of the architects of the CM framework, and he'll be leading today's session. By the way, my name is Scott Wasson. I am the Director of Product Management at MLCommons, and my role in the meeting today will be just sort of helping to moderate as you guys have questions. I'll try to help feed them to Arjun so that he can get through as many question response sequences as possible as he steps through the deck. Feel free to ask questions along the way in the chat, and if we need further clarification, then we can go to voice for further conversation and clarification. It's good for everybody that when we have conversations, we're happy to do it. Just with an awareness of the constraints of time that we have, we're trying to get through a certain amount of material so people have a fuller understanding of how it works. With that, I think I'll hand off to Arjun. You want to introduce yourself briefly, and then we can get going.
Yeah, thanks, Scott. So thanks for the introduction. So I am Arjun Suresh. So I have been working on Collective Mind for almost 2 years. So Collective Mind framework is created by Gregory Wasson and myself. It started 2 years back, and MLPerf Inference was the kind of the test benchmark which we wanted to automate through Collective Mind. And currently, we have done quite reasonable work here, and I would like to showcase how CM is now working for MLPerf Inference. So so in today's talk, I will talk about what CM is and why CM is useful for MLPerf Inference. And then we will see how we can reproduce some past MLPerf Inference submission via CM, and how we can integrate a new inference implementation to CM and make use of the framework to do a MLPerf submission. And also we showcase some of the documentation sites for CM. So in today's talk, we won't be going in technical details about how CM is designed and all. So if anyone is interested in that, we can have another tutorial session. So today's tutorial will be mostly showcasing the features of CM, especially for doing an MLPerf submission. Okay, so first of all, we start with Collective Mind. So Collective Mind, or CM, is a CLI tool which actually helps in creating automation framework. So this tool is a very small Python module which anyone can just pip install. So it in itself doesn't have any automations, but it helps in creating automations. So we use this CM CLI tool and create two main automations. One is called script and one is called cache. So with these two automations, we can write scripts and manage complex workflows. So for MLPerf Inference, we have written maybe 10 to 20 CM scripts. And that is how we manage the entire inference workflow across different implementations like NVIDIA, Intel, Qualcomm, and the MLCommons reference implementations. So the CM workflow, you can consider it kind of a more powerful version of CMake. So it is not like a framework in itself, but basically it connects different components, and components can be anything like standalone package, standalone applications or scripts. Okay, so now what are the benefits of using CM for MLPerf Inference? So the main benefit is automation because we almost entirely automate the workflow for benchmarking. So mostly like you can run MLPerf inference similar to how one can run a spec benchmark. Means like almost like a single script, you start it, and in the end you get the benchmark results. We are still not fully there, but almost there. And then the other benefits are like reuse of the common code. So currently the MLPerf inference benchmarks are showcased like in the form of rules. So any submitter has to follow the rules and then do the basically implement the rules in their benchmark code. So what turns out is that like different submitters create their own workflow, and there is a lot of duplicate code is duplicated among different workflows. So what CM is trying to do is like automate, unify this workflow so that the same workflow is used by everyone, and it makes it easy for the maintenance. So you can see the codes which is unified in CM. So the one is the code to run different scenarios and the compliance run. And then we have the option to do like a test run and a short run. Like the typical inference benchmark need a minimum of 10 minutes. So the short run is typically for 2 minutes, just to make sure that everything is working fine and you don't need to wait for 10 minutes. And then due to wrong inputs, many times the inference runs can be turn out to be invalid. So in CM workflow, it automatically eliminates the invalid runs and do a rerun for those, so that user don't have to like manually do anything there, like deleting the old run files and all. It's automatically taken care of by CM. And then another benefit is the power measurement. So for power measurement, on the hardware side, one needs to have the power analyzer setup and all. But if you are using CM on the software side, there is no nothing extra to do. The user just have to add minus power option, and the workflow automatically takes care of doing all the power measurement setup and all. And then finally, CM generates the submission tree, which is required for doing an inference submission. And then CM workflow can run both with or without Docker. So if you're running without Docker, of course, you have to take care of the system environment and all. But the dependencies for running the benchmark in itself is entirely taken care of by CM. But we still use Docker to ensure that it's a safe reproducibility environment. But the Docker or the Docker file generated by CM is dynamic in nature. Means we can generate it anytime and also like support different OS. The reason for this is inside the Docker file, we are using CM command. So the entire workflow for a submission is typically one CM command. So that CM command executes dynamically inside the Docker. So we are not hardwiring anything inside the Docker file, like a typical Docker file you see everywhere else. And then another benefit is like,
Hey, Arjun,
yeah.
let me interrupt. We got a couple questions. What about Podman and Singularity / Aptainer?
So currently we support only Docker. So yes.
Is there a plan to change that?
So it depends on the request. So currently we haven't got any request for that, but of course, if we have request, we can consider it, because like I told, the generation is automatic, so it won't be that difficult for us to support like other container frameworks.
How do we make the official request?
Typically, we take in all the requests or feedbacks in through GitHub only. So just like give a GitHub issue and we can consider it.
Okay, we'll create a GitHub issue. Thanks.
Yeah, thanks. Okay. Yeah, and another benefit of CM is like this we added recently in the last inference submission round, which is like better dumping of the dependency information. So I can just show it here. Yeah, so this is a dependency dump file. It is not very user friendly because it is in JSON format now. We have planned to create a graph out of it, but it gives a tree of dependencies. So, and also the version. So at any time, the user can figure out like what exact version of each package or software was used in producing this benchmark runs. Okay, so now we can see like how we use CM to reproduce different inference submissions. So here, what we have done is like like Intel, NVIDIA, and Qualcomm are the three main chip vendors in MLPerf Inference. So basically, if we consider all the inference submissions, almost 90% of the code is either from NVIDIA, Intel, or Qualcomm. So we had to add their implementations inside CM. So we added their implementations and also like try to modularize them as much as possible, so that now we have like a unified way of running all the three implementations, which we will see in the coming slides how unified they are. So currently, like it is not fully done. We have done added all the NVIDIA implementations until 3.1 round. Qualcomm also we have done. For Intel, currently we have added only 2 benchmarks. So our plan is to finish all of the benchmarks by this month end. So now, this is the unified command to run MLPerf implementation. So here in the line number 3, you can see implementation equal to reference. So the reference points to the MLCommons reference implementation. So now, if we change this implementation to NVIDIA, we will be running NVIDIA implementation. But there are some other options also we need to change. For example, when it's NVIDIA implementation, the framework is TensorRT. So this kind of change of options is not very user friendly. So for that purpose, we created like a documentation site, which I will share now. Yeah, so this is our documentation site, which we recently made for MLPerf Inference. So if you come here, you can see like basically what are available now. So the first tab shows like all the available, or the left side, you can see all the benchmarks. So we have ResNet 50 for image classification, Stable Diffusion for text to image, and so on. These are the current inference benchmark. So in the next round, we might have a couple more benchmarks. So, and then we have the different implementations. So the implementation depends on the benchmark. For example, ResNet 50 have almost 5 implementation. But if we go to say Stable Diffusion, we don't have a C++ implementation there. And now for each implementation, we have the code for different categories. So the inference has 2 categories. One is the edge and one is the data center. So if we are in the edge category, or like, then we see like different frameworks. So the reference implementation supports 3 different frameworks: ONX runtime, TensorFlow, and then we have a deep sparse, which is from Neural Magic. And then again, for each framework, we have different supported devices: CPU, NVIDIA, CUDA, and ArurCM. And then we have 2 ways to run. Like I told earlier, we can run, the recommended way is to run through Docker. But if someone wants to try, they can also try the native one, where we set up a virtual Python environment and do the CM command. And then we have the different scenarios. So when we click on each scenario, we get the command, which one can simply copy paste and do a run. And the good thing is that now if I click on NVIDIA, then automatically all the framework and all framework device, etc., are automatically changed. So user need not like use their brain to change these options. So most of the time, just copy paste will do the work. And also like we automatically eliminate all the invalid option for each selection. For example, NVIDIA doesn't have a CPU option, and similarly, Intel ResNet 50 is a work in progress. And if you see GPTJ and Intel, it has only CPU device. So this is the
we have a question from the chat, Arjun. Are the benchmarks able to be run on multiple GPUs and servers? How do you set this in your example?
Okay, multiple GPUs. So basically, like if we are using NVIDIA implementation, the NVIDIA implementation automatically detects your system, and if you have like 4 GPUs, it automatically runs on all of them. So currently, we don't have an option to like run on a subset of them, but we will use all the GPUs on the system, and this is for NVIDIA implementation. For the reference implementation, it's usually the other way around. Most of the reference implementation runs on a single GPU only. So so basically CM in itself doesn't do any extra thing there. It directly kind of supports whatever is there on the implementations being used. So does this answer the question?
Yes.
Okay. Yeah. Okay. So can come back. Okay.
One more question in regards to this. We can then do a Slurm allocation and measure a subset in Slurm, because our machines are heterogeneous in nature. So what we have to do is we have to go through Slurm and reserve the partition for whatever we are doing. And then we run that benchmark in that Slurm partition. So that is intended use, or is it only intended you have a homogeneous machine, you have to reserve the entire machine, and you run this entire benchmark on the entire machine?
So we haven't tested on a Slurm setup, but as far as I know, I think it should work, because in the end, what happens is that whatever GPUs are exposed to the implementation, the NVIDIA implementation will be using those. So I think, but heterogeneous, like if different GPUs are exposed to the implementation, I don't think that works as of now, because the implementation assumes that all the GPUs are of the same type.
Okay, then another question that I have run in the past into, when we look at some of the documentations of the examples, it doesn't actually specify how much main memory or GPU memory we are required as a minimum for it. So we put in potentially all this work, and then we find out it can't even be run because the hardware requirements are not being met. Is there some documentation or improvement of the documentation being planned for the examples, which you could easily add to your tool?
Yeah, absolutely. So basically, like I myself face this issue a lot, and even yesterday we got the same request from someone trying to run NVIDIA implementation. So, but currently we don't have it in the web interface. But as you can see, like we have this like just. Yeah, we have this tip option where we are adding like new tips to the users. So here we have plans to add this requirement, especially for the non-trivial benchmarks where sometimes even 24 GB device memory is not enough. So such kind of information, mostly by like in the next couple of weeks, we will add that in the documentation, because it is very useful to the users. Yeah, any more? Yeah, I think we covered all the questions, right? And any further questions?
I think we're mostly current on questions. There were a couple that came by that were duplicates, but I think we've answered them. So
Okay, sure. Okay. Okay. Yeah, we covered the interface. Okay, so yeah, now we can see like what are the steps to reproduce the MLPerf inference submission using CM. So I will explain it through the documentation website only. Yeah, so yeah, so first thing we need to decide is the implementation we are using. So for example, if you want to do a submission on using NVIDIA GPUs, the most suitable implementation will be NVIDIA. And then we have to decide on the category. So as you can see, you might know the edge category is for showcasing the latencies. And the data center is for mainly showcasing the throughput. So if we are doing the edge category submission, then we have only one choice, the framework, and only one device. So we straight away come to the NVIDIA implementation runs only via Docker because it uses the NVIDIA Docker container. So we have this simple like one command. We just have to copy paste it and on a system with CM installed. So we will see how to install CM in the coming slides. So once we copy paste this command, what happens is that it builds the Docker container for NVIDIA implementation. It will take like 1 to 2 hours because it needs to build PyTorch from the source. And after this time, you will be interactively inside the Docker container. And then you can copy paste each scenario commands one by one, or you can go to the all scenarios tab and copy paste this command. So this will do the performance plus accuracy run for the given benchmark, which is GPT-J. And that's it. Once this is done, all the results will be recorded in the CM cache. And then you can continue the same for other benchmarks which you want to submit. And once all the results are done, then we can go to the submission tab. So here is the command to generate the submission. So what this does is it automatically picks up the produced inference results from the CM cache and generates a submission folder, which is valid for the inference submission. You have to give in some options here, like the hardware name, which is the system name, and your submitter name. So to do an MLPerf inference submission, your organization must be registered in MLCommons. And then you can add some extra notes and all if there are like some extra information you want to notify. Yeah, so that's it for the submission.
I have a question about this. When submitting the results, is the command that's being used part of the submission?
Yes, I can show. Yeah, let me show an example there.
The reason why I'm asking this is because we have problems when, for example, a result is being repeated like some time back, and the new people that are coming in, they don't know how to run it. And while making that command part of the submission, it is easier to reproduce rather than just saying, okay, here's the result. So essentially the workflow that you are actually executing, in this case, the script will be part of the result that you submit.
Okay, yeah, actually we have like a setup for that, so which we actually used for the last submission round. So I am sharing that now. So this is the submission done by C-tuning in the last inference round. So you can see like this README file itself is automatically generated by the CM workflow, the same one which you saw now. And now if we go to one benchmark, say ResNet 50 offline, you can see like yeah, this readme, again, this is automatically generated. So this includes the run command which you have given, and also like some extra thing like the commit hash of the repo we used, because that also we need for like exact reproducibility. So yeah, so I think this is what you meant, right? Like the command needed to run the
yeah. I haven't seen that before, but that is exactly what I have been doing with our thing. But naturally, we didn't have CM at that time. Yeah.
Okay, sure. Yeah, so we have like if you see like these files, we have this information, and also like we also save the console output. Yeah, the performance console and the accuracy console. And pip freeze. These are all just for like better reproducibility. Okay. Yeah. Okay. So we covered this. Okay. Now we can see like how like if I told about NVIDIA, Intel, and Qualcomm, and most of the submitters use their code for doing an inference submission. But there can be like other new submitters also, and for them, they have to either like recreate the entire submission setup on their own, but they cannot use CM for that. And we have a real example for this, which is from Neural Magic. So this is the pull request which we did for Neural Magic, showing how we added the deep sparse backend into the CM workflow. So one advantage here was that Neural Magic was extending the MLCommons reference implementation. So we could reuse or like we could just modify the our CM script for reference implementation and add deep sparse framework. So for that reason, if you see like there are only like few changes in this, and then we could just run deep sparse implementation and get a valid MLPerf inference submission. And we have done like hundreds of submissions with the deep sparse backend with this. So now like anyone else using the reference implementation can kind of use this PR and do a submission. Okay, so now if you are like completely creating a new new implementation, then the how to use CM is shown here. So basically, our advice is that you can use the CM copy command. So what CM copy command is that does is that it takes a current CM script and creates a new script with by using it like a template. So with this, like we take a dummy inference script and create, for example, here we are creating the script for Red Hat. And this I just tried 1 hour before this tutorial. And you can see, yeah, this is the PR for that. And if you use now use this script and run, it will fail and show basically this step. Yeah, the run command needs to be tested. I can actually show this. Okay. Yeah. Okay, so here is where we have all the CM scripts. You can see like there is a CM script for NVIDIA implementation, Qualcomm implementation, Red Hat. So this Red Hat is the one which is created now. And now, yeah, so every CM script has the same structure where we have like a pre-process function and a post-process function. So in between pre-process and post-process, we run the native script, which is the run.sh. So you can see these are all like dummy thing for now. So in this new Red Hat one, we are stopping here at line number 30. Like we try to get the run command, but it is not tested. So if we modify this command line number 50 and kind of give all the valid inputs, so we don't have like a Red Hat machine to test it on. But if someone has the access, they can just test this command and fix any missing parameter and all. And then after that, they just need to like return 0 here without the error. It will CM will automatically execute that command, and it is executing on the code base, which is the submission done by Red Hat only. So that is controlled in this cm.yaml file. So here you can see, we are using the R4.0. R means the release 4.0 inference release, and if we are selecting this, it is the GitHub repo is taken from MLCommons inference results 4.0. So
instead of returning 0, shouldn't you return the or joint of the run commands that you had in that script?
So
you had in the preprocess, you had the print.
Yeah,
so
so
you have
here,
to run cmd. So you said you want to have a 0 there, but shouldn't be just simply the or of run command and run dir?
so here actually, like in the preprocess function, we are not actually returning the run command. Actually, but here it's not complete. We can show like a working example. So how it works is that the run command is saved in an env variable, and a later CM script actually executes it. So here, no run command is saved.
Okay. Thank you.
Good. Yeah. Yeah. So that's all regarding the explanation. Now, like we have added some links for the documentation. So the first one is the CM installation. So this is the CM MLPerf Inference documentation. So here first we have to install CM, and for that, we have to go to the CM installation page. So CM is installed, like it's checked on different flavors of Linux, Mac OS, and Windows. And for Ubuntu, we have tested on Ubuntu 18, 20, 22, 23, and also the latest 24.04. And Red Hat 8 and 9, we have tested CentOS 8, and Mac OS, Windows 10, and Windows 11. Actually, in the last round, we even had a native submission on Windows. So to install CM, basically we have to do a pip install cmind, but it needs the some dependencies, which is like the pip and virtual environment, and we also need git, wget, and curl. So if these packages are already installed in your system, you just have to do pip install cmind. But the latest distros need a virtual environment to use Python packages. So now we recommend setting up a virtual environment and then installing cmind. So once this is done, then we have to pull the GitHub repo containing all the CM scripts, which I showed earlier. So currently we are using the repo inside Git overflow. So just copy paste this command and all the scripts will be downloaded into your machine. And those are like a few MBs only, like maybe around 10 MBs. And then, after that, we can go to the benchmark page and choose the benchmark and do the commands which I showed earlier. Yeah. And now, if you want to know more about CM scripts, we have this page yeah, first of all, we need to know about the CM CLI interface. So this documentation page shows like how it works and what are the options and what are the high level idea for each of them. And maybe like if you are interested outside of MLPerf Inference, you can also create your own new automations using CM. Yeah. Oh, sorry, I was not sharing this page. Yeah, so this is the page showing the documentation for CM CLI interface. You can see like what are the options for CM. So in our flow for MLPerf Inference, we are only using CM run script mostly, but outside of it, CM CLI interface has a lot more options. Yeah, and then the CM automation we use the most is CM script, and CM script also has a lot of options, and a part of it I described in the earlier file showing the pre-process and post-process functions. But this diagram shows the entire flow of the workflow when we use the CM script. So the state in the CM workflow execution, everything is saved in the env environmental variables. So like we use environmental variables to pass information throughout our workflow. So when we start the script, we can pass some environmental variables to the script. Then CM runs like the chain of dependencies, and each dependency in itself is a CM script. So if there are no dependencies or all the dependencies are run, then we reach the pre-process function, which we saw earlier. And after the pre-process function is done, then we have another set of dependencies, which we call pre-hook dependencies. So they are run after the pre-process function. And after this stage, we come back to the run script. So earlier, there was a question about the run command. So we were not returning the run command in the pre-process function because we added it into the env variable. So that command is accessible in the run script. So in the run script, again, run script, we have .sh run script for Unix systems, and for Windows, it is run.bat. So that is how like we support different platforms. So most of the inputs are ready for the run script in the Python itself. So because Python, it's easy to support portability in Python. And in the run.sh or run.bat, we just run the command. Yeah, and after the run command is finished, we again have a list of dependencies we call post-hook dependencies. And those are executed. And then we come back to the post-process function where we kind of finalize the output for the script. And then we also have like post dependencies, which are seldom used, but it is more like a trigger. So once this script is done, if you want to trigger something additional, then we use the post dependencies. And this is the how like a single CM script runs, and for each dependency, which in itself is a CM script, entire sequence repeats. And
Arjun, there's a question about what's the URL for the pages being shared? It looks like the doc.mlcommons.org/inference/install doesn't have those pages.
Yeah, so all these links are in this slide. You can see like the first, the CM CLI link is here. Then the CM scripts, which is the one which I was showing now. That link is here.
Okay. And are we gonna run a live demo of making this stuff happen on the system?
I can show it now. So yeah, let me so I have just one more slide. So after that, I can show the demo.
Great.
Yeah. Okay. So yeah, and then okay. Yeah. So yeah, in this page you can see like some more description about the inputs which we can pass to the CM script, and also like how to some of the keywords used in the script meta. Those are also explained here. So now, yeah, and this is like a handy command which we use a lot, which might be useful for developers, which is that if you are using CM, you can dynamically launch a Docker containers, which gives you like a clean environment. And you can test different OS, which are like CM supports Ubuntu, Red Hat, Docker containers. So you can create the Docker container with different versions of those. And this typically takes 5 minutes, and you get a clean environment where you can test different workflows. Okay, yeah. And here there are like some more documentation links, which is the CM API and getting started link. And yeah, we the final link is for the GitHub action, which this is from the MLPerf Inference repo. So we have some GitHub actions here, which are all run through CM commands. So since they are GitHub actions, you can be sure that those are always working, or like are always being tested. So if ever there is some confusion how to run some MLPerf benchmarks through CM, this can be a useful place to go.
Arjun, Steve Bailey asked, how about NVIDIA Docker containers?
Sorry, how about NVIDIA Docker?
Steve, do you want to ask your question?
Okay.
Yeah, I was wondering about the NVIDIA Docker containers. You had the page up where you could instantiate a Docker container. So is it available to use the Docker containers in that also when you specify it, instead of creating a Docker container?
Yeah, correct. Exactly. So like, let me show that.
If that makes sense.
Yeah, sure.
The NVIDIA Docker containers have everything loaded, so you don't have to go through and build some of the models.
Yeah, that is correct. So even to run the inference benchmarks on CUDA device, we use the NVIDIA Docker container. So
Okay.
I can show the example for that.
Remember, you had that CM command that said Docker, and it creates the Dockers, and you give it the.
Yeah. So yeah, that is correct. So that command. Please go ahead.
Can you specify an NVIDIA Docker with that?
So basically, that CM command, which I like you were asking about this this command which I showed.
Yes.
Actually, we can give the base image here. So like I don't fully remember the option. It is like Docker base image something equal to, and then we can give the NVIDIA Docker. That should work. Yeah.
Okay, so you tell it the base image instead of using the Docker OS version of Ubuntu OS.
Correct.
Okay.
Yeah. Yeah.
Okay.
So instead of the OS, yeah. Okay.
Yeah, that makes sense. Thank you.
Okay. Thanks. Okay. Okay. Yeah. So so we that's it for the explanation. Now we have some to-dos. We have to do like better graphical diagrams showing the workflows, and also like the current CM commands is like doing each benchmark one by one. So we would like to like run all the benchmarks on a system in one go. So one bottleneck for that is that we have some manual intervention needed for doing server scenarios where the user have to input the system performance value. So we our plan is to automate that, and once that is done, the second point will also be taken care of. So that's it. And now I will show like I will start a demo showing how to run CM command. It's a clean like Ubuntu system. So I'm okay. Yeah, so I'm going to the CM homepage, installation page, and do. Okay, since it's a clean installation, I am doing like, yeah, I'm doing like sudo update and upgrade. It will take a while. So if you have some questions, I can answer that now.
What was the rationale behind picking CM for the automation framework?
So it is not like we picked CM. It is like we designed CM for that, because there were no other like kind of automation framework which was like uh, which could integrate different workflows. For example, if you take NVIDIA inference flow, that flow is very different from what say Intel uses for their submission. So now, and again, that is very different from what Qualcomm uses. So all these different workflows, there is no like we could not find like any other framework which could integrate all of these like in a much in a better way. So CM, as you could see, like it kind of passes all the information through env variables, and outside of it, there it doesn't control anything. So any native script can work standalone without. I mean, in CM they're almost working standalone. So yeah, I mean, we couldn't find any similar framework which does this, and this is what makes CM kind of suitable for MLPerf inference.
Are other MLCommons groups using it? Is the question.
Oh, other MLCommons groups. So one is the automotive group. So the automotive MLCommons automotive inference group is coming up. So they have their POC going to release in I think it's on June 18th. So they are using CM because in their automation benchmark, the main advantage which CM provides is again the easy for anyone to reproduce the benchmark. So yeah, other than that, only like inference and power. These are the two working groups where CM is being used now. And again, like in CM, for anyone to use CM, they have to make the CM scripts which kind of integrate their workflow inside CM. So currently this is done only for inference. That is why inference and power. So we could do the same for training, but we haven't, or like we don't currently have the manpower for that. We have a couple of CM scripts for training which we used for our like for C tuning submission previously, but it was not like a complete flow like we have for inference. Like copy pasting the commands one by one from the CM installation page. So I have done sudo update and installation of pip and virtual environment. Now I am going to create the virtual environment and activating it. Yeah, now virtual environment is activated, and now I am installing CM. Okay, CM is now installed. Then I need to pull the GitHub repo with all the CM scripts. So now I am doing this. And as you can see, it is very fast. It's because it's only like script codes are there. Now this is done. And now I am going to the benchmarks page. And yeah, let's try one BERT email. But
And so what we can't see is that you're just copying and pasting from the documentation the different commands that are specified there.
Yeah.
Yeah.
Yeah. So, okay. Okay, so now I am copy pasting the virtual environment setup for Python of BERT large from the documentation page. Yeah, and now doing the run command. Okay, so yeah, this will take a while. It will download the dataset, download the model, do the pre-processing of the dataset, and then call the inference implementation, and then do like a test offline scenario run. So it's expected to be like 5 to 10 minutes it can take. So any further questions?
Parush Gupta is asking, could you please add the steps here or share the URL? I think all these steps are in the documentation page, which we have shared and pinned above. I can paste the link again. And I think what you started with is install CM, and then what did you do after that? Was it
So
download
those
the
so those
repo,
are
right?
yeah, so those are in the yeah, let me share the page once more.
Yeah, and here is exactly the point that I tried to make earlier on with the data. So we have some applications that we naturally test outside of inference that require 40 terabytes of data. And the constraint of how much space is needed for the data set should be integrated into that workflow, so that if something goes wrong, you have at least the message coming out, okay, there is not enough space available now, which you can request via the du command or df command or whatever other commands you have on these particular machines. I understand that you try to create this as general as possible on Windows and other platforms, but I think you may need to be adding to your framework a free function, or how much space is free, so that could be a valid question that is being posed to the system where you're trying to run this on.
Yeah, absolutely. So for example, like we don't want to spend like 3-4 hours and then getting a command, getting an output showing that the disk space is not enough. So in we have plans to show like at the start itself, like uh, uh, we will show that to the user, like, okay, this command will need say 100 GB of disk space, but currently only like 50 GB is available. So yeah, you should like it will be like a warning to the user, and they have to only like if they proceed force it, they can continue it. Otherwise, they will be asked to like increase the disk space. And yeah, this the same request we had got before also, and yeah, I think it makes sense.
And this is a future edition, right? This is not implemented yet.
This is kind of like this feature is there. Warning feature is already there, but we have to like add the information for different script, right? Like how much data disk space each of the scripts needs. So that information we have to feed in. We
Okay.
have it for some like really large ones, but not. It's only minimal as of now. Yeah, so yeah, coming back to the commands which I did. So it was from this installation page, and first we have to go to the CM installation page. So these are the commands I copy pasted: the sudo update, upgrade, installing the Python dependencies, then activating the virtual environment, and then finally installing cmind. And
Yes,
then
thanks.
yeah, this pulling of the repo. So these are all in the link in the slides itself. Okay.
So is this repo the same as the one that's on GitHub?
So we have actually 3 GitHub repos. One is the one for CM, and one is the one for CM MLOps, and then we have the inference repo also. So
Yeah.
so this title basically means github.com/gateoverflow/CM MLOps. So GateOverflow is a fork of the like the MLCommons repo. So yeah, currently we have the updated scripts here. That is why I'm sharing the fork link. But if you go to the fork, you can also see the original repository, which is MLCommons at CM for MLOps.
Okay, thank you.
CM has kind of installed all the dependencies, which you can see.
And this
the,
is because you copy the benchmark command, right?
Yeah.
Yeah.
Yeah. So now it is like actually doing the benchmark. It is on CPU, so it will take a while. But the whole setup is already done. All the package dependencies, framework, dataset, model, all are taken care of. Yeah.
I had a question, Arjun. So if
Yeah.
you need to change any parameters or the config file, how do we do that? Do we have to do that before the command?
So like, for example, like what kind of configuration are you specifying?
And running any, right now you're running an offline scenario, and I want to change a couple of parameters. Is that possible?
Yeah, it is possible. For example, whichever parameters are supported by the implementation, we expose them. For example, NVIDIA implementation, if you are using, we can change the batch size. We can change the number of threads. So those kind of options, we haven't added those in the documentation website, but we will add it there. Or for now, if you go to the the meta file of the script, it is there. So yeah, I mean, currently, if you are running, I think the meta file, which is the YAML file, will be the place to see. Yeah.
Got it. Thank you.
So that would be for that specific script that you're going to run then, correct? Is for the YAML file, whatever's in there is what it accepts?
Yeah, that is correct. Yeah.
Okay.
So yeah, but we will add it in the documentation itself because
that's why I was wondering if there's an easy way to see what the scripts actually accept and don't accept.
Yeah, that's correct. Yeah. So yeah, we will add it there. Yeah. And yeah, as you can see, like now this was a test run, so that is why it finished. The QPS was only 2, so normal valid run would have taken almost 2 hours, but we give only test I think 10 or 100 inputs were there. So the run is finished. We got a QPS for the bug 99 offline scenario.